Good day, class. In this video, we will review how to use the Pythagorean theorem. So you can see here a right triangle with side lengths A, B, and C. C is called the hypotenuse of the triangle, while A and B are the legs of the triangle. We have, of course, the relationship A squared plus B squared is C squared. So we'll just go through and solve a few examples here. We're going to determine the unknown side length and round our answers to the nearest 100th. So here's a first example. We have A is 24 and B is 15. C squared is A squared plus B squared. So it is 24 squared plus 15 squared. Now we can use our calculators to punch in 24 squared plus 15 squared and then push equals. And you can see we get 801. So C squared is 801. And now we just take the square root of this number. And here we're going to round to the nearest 100th. So to 2 decimal places, this will be 28.30. So that's the approximate length of side C. Let's take a look at the next question. Now here we have A and C given. We have to rearrange this formula so that B squared is isolated. So this would involve subtracting A squared. So the formula becomes B squared is C squared minus A squared, like this. Which means that it is 31.6 squared minus 14.2 squared. And again, this value you can work out with your calculator. Minus, Okay, you can see you get 796.92. And then if we take the square root of that quantity, we will have our length B. So 28.23 would be correct. And that has been rounded to the nearest 100th. Okay, question 3. This situation is exactly the same when you're trying to solve for A. So here we're given both B and C. Rearranging for A will mean subtracting B squared from both sides of the equation. So we end up with C squared minus B squared is equal to A squared. So this is 315 squared minus 123 squared. Okay, you can see this is 84,096. And then take the square root of this and you'll get your answer. So rounded to 2 decimal places, this is 289.99. Okay, so the key to using the Pythagorean theorem is you're adding only when you're finding the length of the hypotenuse, which is the longest side of the triangle. It's directly opposite the right angle, and in this case, we're calling that C. When you're finding one of the legs of the triangle, you're going to be using subtraction like this. Okay. And one last example, I thought we could turn to your textbook. This is page 219, and let's take a look at problem 8 together. Okay, so I'm going to put that on the screen for us. Okay, right there. So let's go ahead and read the question. So the problem reads, the 24-foot ladder in this figure is used to make a service entrance connection on a building. The bottom of the ladder cannot be more than 6 feet from the building. What is the minimum height at which the ladder will be touching the building? Okay, so you can see we have the building here symbolized by the bricks. The fixed length is the length of the ladder. It is 24 feet. Again, the furthest distance allowable here is 6 feet. And of course, when this is at its furthest distance, the height here will be at its minimum. So we simply want to solve for this missing leg here. So if you like, you can begin by drawing a little diagram like this on your page. Okay, so on this diagram, we can list 24 feet here and 6 feet here. And then we have our missing side length. And here you can call this what you like. I'm going to use H for height. And now, of course, it's H squared plus 6 squared is equal to 24 squared. So this is H squared plus 6 squared is equal to 24 squared. Since this is the hypotenuse right here, so it is the longest side length. Okay, so another way of writing this, of course, is H squared is 24 squared minus 6 squared. Like that. Now we can use our calculator. 24 squared minus 6 squared. This is 540. Okay, take the square root of that and then round to the nearest 100th. So the 3 is in the position of interest. The 7 beside it means we round this up to a 4. So the height would be roughly 23.24 feet. Okay? And this would be considered the minimum height because, again, the maximum distance here is 6. So when the ladder moves closer to the building, of course, its height would increase. So the question asked for the minimum height. You could write a concluding sentence here if you like. You could say the minimum height of the ladder is 23.24 feet. Okay, but I will not insist that you write a concluding sentence with your word problems, but what is important when you are solving a word problem is that you do include the unit on your final answer. Okay? Okay, so that was a short video on the Pythagorean Theorem. Please check Blackboard for the recommended homework for that. And look for the next video. The next video is entitled Trigonometric Functions. And here we will use the 3 main trig functions, sine, cosine, and tangent, to find both missing side lengths and missing angles in right triangles. Thanks. Have a great day.